Alright guys, we're going to talk about factoring quadratic trinomials. I'm going to go right into it just because there's many things to talk about. It's possible that I may have to make 2 videos, but we'll jump into it and see how far we can get. Okay, the first thing we need to understand is the idea is I want to find out the pieces that multiply together to make a trinomial. So let's look at it. This means FOIL. When I FOIL this, I get x squared plus 4x plus 2x plus 8. And when I combine those together, that equals x squared plus 6x plus 8. This is a trinomial. 1, 2, 3 terms. This is a trinomial. Today we're going to start here and try to work our way back. Alright? So how do we actually factor trinomials that look like this? Well, we first always look to factor out a greatest common factor. You won't always have one, but always look for it. At 100 problems, 99 of them may not have it, and then on the 100th one it may. So always look for a greatest common factor. Right, 2 empty sets of parentheses. In the first position, notice here where the little underscore is. In the first position, in parentheses, they have to multiply to be the first term. The last parentheses have to combine, meaning add or subtract, to be the middle term. So let's jump straight into it, and hopefully you can understand or see these steps, all right? First of all, look to factor out a greatest common factor. There is no greatest common factor. It almost looks like you can pull an X or a 2, but you can't. It has to be an all. The second step is to write 2 sets of empty parentheses. The next step is that the first number always multiplies to be the first term, which is x squared. So x times x is x squared. Whenever your leading coefficient is 1, like it is on all of these, it's easy to always know what variable goes in the beginning. Now, what number goes in the second part has to have 2 parts. It has to multiply to be the last number and add or subtract to be the second number. So the way we fix that is we list all the factorizations of the last number. All the numbers that multiply to be 8. Which one of these combinations can give me a 6? The only one that can give me a positive 6 is a 2 and a 4. A positive 2 and a positive 4. Now we know a positive 2 and a positive 4 multiply to be 8. So we write plus 2 plus 4. But guys, it don't matter if I do this. This means the same thing here. So the order of these parentheses don't matter. So either one of these is okay. So I'll put like a or in there. This one or this one. Alright? Let's look at number 3 here. Notice my variable change. So what? Rule number 1, look to factor out a greatest common factor. There isn't one. Rule number 2, put 2 empty sets of parentheses. Rule number 3 says in the first position, put what multiplies to give you an a squared, which is an a here and an a here. Alright? Now, the second and the fourth step is to list all the numbers that multiply to be negative 35. So 1 and 35 and 5 and 7. Out of these two number combinations, which one of these can add or subtract possibly to give me a negative 2? There's no way I can get a negative 2 out of 1 and 35. Does a positive 5 and a positive 7 give me a negative 2? No. Does a negative 5 give me a negative 2 when I put those two together? A negative 5 plus 7 gives me a positive 2. The only way I get a negative 2 is by negative 7. So 5 minus a negative 7 equals negative 2. And 5 times a negative 7 equals negative 35. Notice, guys, that you have to pick 2 numbers that meet both of those standards. What standards? Well, they have to multiply to give you the last term, including the sign, and add or subtract to give you the second or the middle term, including the sign. You can't pick numbers that only do one. So once you find them, that's a positive 5 and a minus 7. Again, it don't matter the order. That's how that factors. And if you ever wanted to, you can multiply it out or FOIL it back out to see if it works. A times A is A squared. A times negative 7 is negative 7a. 5 times a is 5a, and 5 times negative 7 is negative 35. A squared comes down. Negative 7 plus 5 is negative 2a minus 35. See, it works. So you can always check. All right. You can work number 4. I would like for you to try number 4, but I'm going to move down here to number 5 and 6. Now, this is not 3 terms. I'm talking about factoring trinomials. But this also factors into 2 binomials. How do I know that? This one has a special name. It's called the difference of squares. Yeah, I'm being lazy. Difference of squares. Difference means subtract, and squares mean both of these are perfect squares. If you can recognize that whenever you have 2 terms and they're being subtracted, and both of those terms are written as perfect squares, then it would always be the same number in each parenthesis, except they'll have different signs. The middle terms will subtract out when you FOIL those out. So a difference of squares shows up from time to time, and you'll know it because it has 2 terms and they'll be subtracted. Another way to look at this is x squared minus 2 to the second power. That's the squared part. See, they're both written to the second power. If you can make your number written as something to the second power, then it's a difference of squares as long as it's 2. But it's not if you have x squared plus 4. You can't do it then. If you had x squared minus 6, you couldn't do it then. Why? Because 6 is not a perfect square. It has to be 2 terms being subtracted, and both of them are perfect squares, like 4, like 9, things like that. All right? You'll see more of those as they come along, and I just wanted to introduce it today. Finally, let's look at number 6. The first rule on every single one of these is to look for a greatest common factor. Oh, so far, we haven't had one, and so now I'm going to show you what it's like to have a greatest common factor. Notice that each one of these has a 5. So I'm going to factor out, well, a factor of 5, I should say. And they all at least have one x. So I'm going to factor out 5x. And what I have left is x squared minus 10x plus 9. Now, normally we would stop right there. But notice, if I just cover that up for a second, that's a trinomial that possibly can factor. So whenever you factor from here on out, you have to factor until you can't no more. I don't know ahead of time that this is going to factor, so just in case it don't, this would be my answer, but we're going to check it out. What goes here? I ignore this, but I keep bringing it down. X goes here. Why? Because what goes in the first position multiply to be that. Now what goes here? Well, the factors of 9 are 1 and 9 and 3 and 3. The only way I'm going to get a 10 is out of these two, and it has to be a negative 10. So how do I make a negative 10? Both of those have to be negative 1s, okay? So minus 1. And I said negative 1s, but negative numbers, and minus 9. So the way this breaks down is all 3 of these pieces multiply together to give you this original problem. This is the factored version of our original problem. All right. Okay, so switched over a little bit because I want to talk about how to factor things that look like this. Notice you got a number in front of your leading coefficient. And so today, or the next few seconds of this video, is about trying to figure out how to work stuff out like this. First of all, we want all of our expressions written like this, and you need to know the quadratic function standard form. The number or the coefficient with the x squared is called a, the coefficient with the x is called b, and the constant is called c. So whenever I say a, b, and c, I'm talking about these specific numbers, so keep that in mind. So here's some instructions about how to factor. So you might want to use a separate sheet of paper for these notes, okay? For these notes are going to talk about something a little bit different. Similar but different. All right. So first thing, we want them all written in this form. Now, here's a step-by-step procedure. Now, this procedure is kind of abstract, meaning you don't hardly ever see this anywhere. But it works because the only other way to do this is called guess and check, where you just keep filling numbers in and pulling out, see if it works. Put more numbers in, fill it out, and see if it works. This will work every time if it factors. All right, so let's keep going. What we're looking for is the 2 pieces that multiply together to give me this, or the 3 pieces, or whatever. If it factors, we know it's going to factor into 2 binomials. Remember, we presume that. We assume that that's going to be the case. Now, how do you work it? Okay, this tells me to multiply a and c. Look up here. Where is a and c? The first coefficient and the last number. So off to the side, I write 2 times 3. And that equals 6. Then I list all the factorizations of that product. So everything that multiplies to be a 6 is 2 and 3 and 1 and 6, right? Then pick the number combination that combines, meaning add or subtract, to be the middle coefficient. So which one of these two numbers can add or subtract to give me 7? Pairs of numbers anyway can give me a 7, and that's 1 and 6. It's a positive 1 and a positive 6. Now you have to check. 1 times 6 equals positive 6. 1 plus 6 equals positive 7. So we cool there. Here's where it changes up a little bit. Now you divide both of those two numbers that you came up with by a, like a in this statement, which is 2, and then reduce to fractions. So I'm going to take 1 and divide it by 2, and 6 and divide it by 2, and reduce them if they can. 6 over 2 is actually 3, and if it's a whole number, you keep it over 1, and 1 over 2 did not reduce. Okay? So once you find those two numbers, a new step is to divide them by a, which is the leading coefficient. Now, both of these turn out to be the answers that go in here. Remember, the first numbers in each one of these got to have an x in it or a variable in it because that's what gives you that x squared. The denominators in step 5 are the first in the binomials and the numerators are last. Each one of these fractions here turns out to be a binomial. The denominator goes up front with the variable, 2x. The numerator goes last. It's positive, so it's plus 1. The denominator goes up front, x. The numerator goes last. Since it's positive, it's plus 3. This works every time if they factor. I'm going to keep going so you can see more of this. All right? I'm going to repeat this process on number 2. So notice that number 2 is written in that form. So I have a coefficient here other than 1. So I'm going to say off to the side, 3 times negative 11. You got to include the sign. That equals negative 33, right? So that's 1 times 33 and 3 times 11. That's the only number combinations that's going to get you a 33. Which one of these number combinations can give me a 32? It has to be 1 and 33. But how do I get a positive 32 out of these two? I have to have a negative 1. If the 33 was negative, it would be a negative 32. But check it. Does negative 1 times 33 give me a negative 33? Yes. Does negative 1 plus 33 give me a positive 32? Yes. You have to check that first. You can't just assume that it's always going to work out. You got to check it both. Once you come up with those two numbers, you divide those two numbers by a. In this case, a is 3. So I divide both of those by a, and notice I divide by using a fraction. And you simplify if you can. Again, if you get a whole number, keep it over 1. So negative 1/3 doesn't simplify, and 11 over 1 doesn't simplify. So again, this factors into two binomials. The denominator goes up front. The numerator goes last. Over here, the denominator goes up front. The numerator goes last. On each one of these, if you want to check me, FOIL them out. But the time I have, I got to keep moving. Let's look at number 3. Can I factor out a greatest common factor? No. Do I have a number other than 1 as my leading coefficient? Yes. And so if this factors, it factors into two binomials. So I'm going to do the process up there that I just showed you that hopefully you wrote down. It says take 6 times 5. 6 times 5, if I can write, equals 45. What are the number, Lord have mercy, 6 times 5 is 30. What are the number combinations for 30? You have 1 times 30. You have 2 times 15. You have 3 times 10. You have 5 times 6. What am I missing? 3, 10, 2, and 15. 1, 2, 3. I believe that's it for. Notice that none of these number combinations here can add or subtract to give me a negative 9. What that means is that this one is prime, or it does not factor. If you can't find a number combination that works, even if it works for one number but not the other, then you don't have a trinomial that can factor. And so all of them won't be prime, some of them will, all of them won't. Now, if you got questions over this, go back through and look at the steps. I modeled the steps on each one of these. If you don't do it like this, what will happen is you'll end up guessing and checking and keep going through. If you got another shortcut way to factor these, let me know, bring it to class, and discuss it. We will. Bye-bye now.